Starting the recording. Okay, here we go. This is the Mechanically Challenged programming meeting for March the 20th, 2023. This is going to be over the Neo encoders and setting soft limits and other variable settings that we will need for the drive station to be able to create some software limits and keep from tearing up a robot by stupidly overpressing buttons. Today's meeting will be mostly over the SmartMax code and what we can do to incorporate that into our own code. We're going to start a new code base tonight. So everybody, if you would like to, let's go ahead and let's get started. I'm going to share my screen. And that screen needs to be the screen 1, 1080p, 30, quality, custom, go live. Okay, I have a stream up and ready to go. Let me know when everybody has visual and if everything is they're able to see everything properly.
Yep, I can see it.
I can see it's just not really zoomed in much, so I'm trying to figure out how to.
Not zoomed in much.
It seems to be really zoomed out. Oh, I can see why. Now, never mind. It's because you're not. My bad.
You want me to go full screen with it?
It don't matter.
I mean, that just opens up a bunch of empty space over here on the right if I do that. What matters is, can you read the text okay?
Yeah.
John?
I can.
Alright, let's get cracking then. So for today, we're going to go over, I believe I have 4 different projects that SmartMax released to us, that Rev Robotics released to us. And we're going to create our code for the robot for this event, which is Green Country. So if you will, go ahead and start your VS Code, and we're going to go over this together just so y'all remember, because you're going to do it on the drive station tomorrow, or you can use Subversion to get the code tomorrow. It all depends on how much work y'all do tonight. So we're going to hit the WPI lib command up here, and we're going to create a new project. We're going to select the type. We're going to go by example, Java, and we're going to load up a tank drive. We're going to pick our folder. In my case, I have it in my documents in 2023 charged up. Select folder. Project name is going to be Green Country. Create a new folder. Our team number is 7483, and we're enabling desktop support. Generate project, new window. And we're going to let that gen up what it needs to gen up. You'll see it down here. It's building, blah, 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 checking details. It's done. We'll go to source, Java, robot, and there we go. We've got a tank drive robot with PWM SmartMax motor controllers, but we need to change those to what, John?
Can.
Hmm?
You asked where are you? Okay,
I asked
repeat
what
your
kind of
question.
motor
Yeah,
controller we...
I'm sorry. What kind of motor controller we're using?
Yep.
We are currently using, is it not SparkMax? What's it called? I forgot the name of it. I'm going back to check my other code. Give me just a second.
Great, do you know it?
Type of motor controller?
Mm-hmm.
Victor Spark?
Very good. Victor SPX.
What he's oh, you cut out for a moment. My bad. I think my Wi-Fi is having a bit of trouble trying to keep up with the stream.
See some new projects.
Okay, so we got left motor controller and right motor controller. But what's wrong with this? Do y'all remember what's going on here? Why this right here is not going to work?
I'm trying to read that.
What?
That is.
Do I need to make it bigger?
No, I'm reading it. Talking about the motor controllers, is it the channel?
Nope.
John?
Channels are part of the problem, but that's not the major problem. So let's open a sixth window here. Open folder. Let's go back and look at the AR Regionals code. Now this is stuff that you guys, by this point, should have memorized. And I want y'all to... The fact that y'all don't have this memorized tells me that y'all aren't working in the code enough. Go back up here to the top and remember what we've got here. We've got these PW and Victor Sparks. Remember, each motor has its own controller channel. So we got left, left, right, right, left A, right, and then we pull that into a motor controller group, not a motor controller itself. Correct?
I must have missed it because I thought that was the motor controller group and not just each individual one. Was I just incorrect in seeing that?
So let's bounce back over to Green Country. So what we got here?
Right.
So we've got left and right as a motor controller, not as a group. So that's not going to work for us. So we're going to drop our Victor XPXs in here for each motor. We're going to get rid of the default code because we're doing individuals. And then what are we doing, John?
We're combining them into a motor controller group. Can't talk today.
Right?
So you have the names already set. You're just using the same names and such.
Might as well.
Fair enough.
Okay, we've got red squiggly line. What's wrong with the red squiggly line? What does that mean?
Import.
Error.
Import. Well, duh. Okay, Gray. Love you, buddy. But yes, red squiggly line means error. We get that. But what kind of error does it mean?
I mean, he's not wrong.
He's not wrong. It's on me for asking the dumb question to get the...
Configure my screen.
Okay. So, back to the main question. John, you had the answer. What is it?
We need to import the motor controller group.
Exactly. The easiest way to do that I've found is to backspace one letter, hit spacebar, pick it out of the list, and bam, it adds it for us.
What?
None of us having to do any special crap. You want to see that again?
Yeah.
Okay.
Dude.
And we'll get up here and we'll grab the import. I'm going to remove it. Boom. We've got red squigglies. Great. What do the red squigglies mean? What did the red squiggly errors mean?
Import errors.
Import errors. We got imports up here. These libraries have not been imported. John, can you tell me what a library is?
The library is the separate area where we have the import that or there's a list of items in our code that tells us what each item is, and that's the library.
Okay.
I need to come up with better wording.
That's close, but what a library actually is a bunch of pre-written code that you don't have to write again that does a specific function. So in this particular case, it does all the interfacing with the motors for us. So we don't have to do any special coding, because if you actually went and looked at these libraries, they're flipping huge. I'm talking hundreds of thousands of lines of code. You don't want to write that every project, so you write one special library that you can bring in that will do that stuff for you every time you import it. Make sense?
Yep. Hence why whenever you do import things such as the stick your SPX into certain new projects, it doesn't have to bring up an error. You don't have to write all that over and over.
Exactly. On top of that, it also throws the yellow squiggle error, which means you imported a library that you're not using. Can anybody tell me why that's a cautionary issue?
You could be using a separate thing, or in the case of having it, it could cause an error and represent that it kicks that up instead of something else that you need.
Okay, that's a good one. Great, what do you got?
Crap. I just accidentally deleted something. Can you repeat the question? Sorry.
Sure.
There'll be a lot of this.
Yellow squiggly. Yellow squiggly means you've imported a library that you're not using. What could be cautionary about that?
It means that there's certain parts that aren't being used, and if those parts aren't being used, could it like be triggered by something that is related to it?
That's similar to John's answer. And that is a good answer. You could have something that's called motor controller group that is used by two different libraries that mean two completely different things. Now that's not going to happen in not Rev Robotics, in First Robotics, because they're very careful about that. But in the real world, I can't tell you the number of times that I had something called a TIFF image, and one library called it TIFF image, another library called it TIFF image, and those two libraries are completely different and do different things. And so it would throw an error. So importing something that you don't need, you don't want to add that level of confusion of having it in your project. But the number one reason why yellow squigglies they're not bad, but they're not good, is that it just adds bloat to your code. You're adding a bunch of crap that you're not using, so when you go to debug, you got to play guesswork at what's good and what's bad, right? You want your code to be the goal of a programmer is to write as much code with as little characters as possible. Let me repeat that. It is to do the most with the least. Do y'all understand?
I overcomplicated your question.
Yeah, but you answered it correctly. Gray answered it correctly, but it's a lot simpler than that in the long run, and that is to do the most with the least. Anything that you're not using, get rid of it. That includes commented out code. Y'all remember that abomination you brought to Arkansas Regionals that I blew away and gave you new code with?
That
Yeah.
I thought we had removed the comments from? Yeah.
Y'all had an F ton of comments. That's bad. For one, it takes flipping forever to get to good code. Second of all, the way y'all had your comments in there, you would have comments for a half a mile and then one line of code, then another half mile of comments, right? So when you're scrolling and trying to find something and you're under stress, and were y'all under stress at competition?
I'd say yeah.
Yeah. That's how competition is. It's stressful. It takes a lot of work. So you need to be able to get to the thing as quickly as possible, right? So yellow squigglies, if you have a yellow squiggly, find out what it is and remove it. You don't need it. It's telling you this is not being used. Let's get rid of it. Red squiggly. Back to this. So I've got a red squiggly here. The easiest way to add a library in WPILib. This is not everything, but WPILib is pretty smart software. And the easiest way to do it is go to the very last letter of the thing you're wanting to import. In this particular case, motor controller group. Backspace, then hold down your control key and press the spacebar. It will tell you that the motor controller group is part of this library, and it's dot 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 it ellipsed out because it's effing long, right? If you want to add it, just reach up here and click it. And now, red squigglies went away. And if I scroll up, look what it added.
I did not know they just added that from the library until now.
Yep.
I have gone back through and Control C, Control V that so many times, you have no idea.
Yep. So that's how you fix that. There's no. That's a real easy. You're going to learn that hitting Control Space is going to auto finish a lot of stuff. Take for instance, we got right motor controller, right? And it's not a bad. It's a bad red squiggly. Well, how do you fix that? Well, you could reach up here. You could double click this, Control C, double click this, Control V, or you could reach down here on right, hit Control Space, click it out of the list, and let's see, highlight it all, underscore right, click it out of the list, and there it is. Let's say I want to set underscore right dot set, and I want to set that to 0. See how I did all that without having to type the entire thing out? Just hitting Control Space, picking what I want and hitting enter will auto write the code for you. It's called inline editing. And every software language that's worth anything has that built in. The one exception is C++, because C++ is a right bastard, and they do not. It's specifically hard on purpose because it does not want a person who does not know what they're doing to write code, because it's like this. You can have a car with an automatic transmission, and just about anybody on the planet can get in said car, put it in drive, press the gas, and go forward, right? C++ is that manual transmission car with a really hot clutch like Miss Cooper's car that it takes someone with some practice. I mean, I know people that drive I know people that drive manual transmissions that still can't take off in Miss Cooper's car because of how hot the clutch is. So what you want to do is you have to know your language inside and out to work with those hot languages, C++ being one. So try to gravitate towards the more open languages like Java, like Pascal, like C#, so on and so forth. C++, leave that to the masochist. Okay?
Okay.
Alright, so I set my M right. I've got M motor left and M right motor. We know that those aren't good. What are those supposed to be?
M left and M right.
Very good.
Well,
M.
For you, it'd be M right. Yeah, M left and
M left. And M underscore R enter. That was not an enter. Enter. There we go. And there we go. So we got our two joysticks, port 0, port 1, and our tape drive is good to go. Except we don't have a differential drive. Yeah, we do. Never mind. My bad. It's right there. Okay. So does anybody have any questions about that? Everybody follow along? Everybody got their code up to snuff?
What are the ports on the motor controllers?
What are the ports on the motor controllers? Excellent flipping question, because this bites y'all in the butt every time we go to competition. John, answer the question for the man. What are the ports on the joysticks for?
The ports on the joystick represent on our not PWM. What's it called? So we plug in our wiring. That's where it's like each area has a specific set place where it needs to be wired, and that will represent where it goes on the code. The code
Wrong.
Oh, am I thinking something else?
Yep, you are.
I'm thinking channels.
Port 0, port 1. Port 0 is the first port on when you go into Drive Station, it lists the controllers in order. Port 0 is the top one, port 1 is the second one, port 2 is the third one, port 3 is the fourth one. You can have up to 4 controllers at any given time on any given drive station. The thing is that 9 times out of 10, and when we practice, it seems to work correctly, that port 0 is always going to be the left, port 1 is always going to be the right. And we can set that on the... I know what the problem is with the flipping joystick. I bet you anything, if we take it off the drive station board, flip it over, you need to set the left one to the left toggle on the bottom of the joystick. Flip the right one over, set it to the right toggle. Making a note of that right now. Over in the build channel. It just dawned on me what was going on with your controller.
The controller's off of the board to do that.
Do what?
Yeah, the switch is on the bottom of it.
Yeah, the switch is on the bottom where you screwed the screw into the bottom of it. You're gonna have to back that screw off, flip it over, and it's a toggle switch on the bottom. And it'll ask you which one is the left controller. Bet you anything, bet $1 against a donut that's the problem. So I'm going to make a 0. Remove controller from drive station, flip left toggle on left, flip right toggle on right. Okay, it's a good thing we're having this session. I had totally effing forgot that until just now. I bet you anything that was what was happening to us at regionals. Okay, so great question, Gray, because that got us thinking about that, and now we can try to fix that. So if you look at like I said, if you look at the drive station, which I don't think I have drive station installed on my desktop because there's really no reason, and I don't. But if you open up drive station tomorrow and look at it and go to the 3rd tab on drive station, John can show you. It's where we rescan the controllers every time.
It's the 4th tab.
4th tab. My bad. The 4th tab. If you look at the 4th tab, it'll tell you the port numbers of where the controllers are.
Okay,
so,
Grayson, do you remember whenever we hop up into drive station to practice, occasionally I'll go to that 4th tab in drive station and swap the glowing green text after pressing rescan?
Yeah.
You know what I'm talking about?
Yeah.
That's the ports.
Yeah. So if you set those to ports, port 0, port 1, port 2, port 3, then you can since you know what port that controller's on, you can give it a name. And then you can assign that name to a position. Otherwise, it doesn't matter what it is. It's always going to be that, right? Okay. Okay, so does anybody have any questions, comments, or anything about any of that?
No.
Alright, let's get back to our purpose for tonight, which is... Good God, I've got so much of this. Soft limits. So the soft limits we're talking about, we got the smart dashboard. John, do you remember how to enable the smart dashboard?
Do you mean on the drive station, or do you mean
on the drive station? Yes.
On the drive station, I do not. Oh wait, yes I do. Yes I do. You go out to the menu settings, go over to the little tab, press enable smart dashboard, and it'll bring up a little menu on top, not on top of it, but over on the side.
Yep, that you can then set up. Okay, so smart dashboard is one of the imports that we're going to have. CAN Spark Max. Can anybody tell me the difference between CAN and PWM?
If you asked me that question 3 days ago, I probably could.
Alright, you guys suck at studying. You're going to have to get better at this. CAN allows for bidirectional talk. PWM only allows one way. What do I mean by that? PWM means I, the controller, am telling the RoboRio, am telling the motor controller to go, and it's going to go. It'll go forwards and it'll go backwards.
So CAN is telling it to go to a certain angle.
Not
No.
angle,
CAN
the
says go forward, and then what CAN does is the RoboRio tells the SmartMax go forward, and the SmartMax says, okay, Rio, I'm going forward. I'm still going forward. I have went forward 3 rotations. I went forward 5 rotations. I have went forward 10 rotations. And so it's talking back and giving the Rio information. Make sense?
Yep.
Okay. The problem with CAN is that you have to give the device an ID, because CAN is a telephone line. Now, it's not the type of what you're thinking of as a telephone line, but it's what we call a telephone line. Is back in the day, before telephones became what they are, even in your parents' times, in the very beginning, there was one cable, and it went to everybody on the block. And if I picked up my telephone, I could listen in on Mrs. Marjorie talking about Father having an affair with Father Peters, and I could listen in and I could hear everything that they're saying because we're all on the same telephone line. That's how CAN works. CAN is one wire that's hooked up to everything, and each device gets an ID, which then allows them all to talk at the same time at different frequencies. Just like I'm talking and John starts talking, we're both talking, but we're both on the same line right now, right? But Gray can tell that we're both talking because my voice is on one frequency and John's is another frequency. Does that make sense?
Yeah. I remember you bringing up that example at one of our previous meetings.
Mm-hmm.
I just happened to forget it at this point. I apologize.
Don't apologize. Try to commit it to memory and let's go. I need y'all to pony up. Okay, so we're going to give it an ID. And in this particular case, we're giving this particular motor an ID of 1. Then we're calling that motor M motor. And then with M motor, we're assigning that ID and we're saying it's a brushless. Why does it matter if it's a brushless? Because brushless motors have a different frequency output than regular motors. Let's go look at your code, because that may be something that we're missing over here in your code for your motor for your SparkMaxes. So if we look here, we've got a SparkMax here, and then we've got the grabber, which is on channel 7, and the lift, which is on channel 1, and we never declared that they're brushless. So that may be something that we need to look into with the motors going forward. But if we wire them CAN, which is what one of y'all's assignments are for tomorrow, then that shouldn't be an issue, right? Because you're going to declare it just like you've got it here as a CAN on a device ID and calling it brushless. So let's say I have 2 motors, because you guys do have 2 motors. Then what would I be declaring here? I
You
would,
declare the ID of the motor.
so I'm going to call this device ID, in this particular case, I would call this device ID, let's say, we'll call it 1 lift, device ID lift, and then I would need another one, private, static, final. See, I'm not having to type anything, I'm just typing the first couple letters and enter. Int device ID, and I'm going to backspace and call it extend. and I'm going to say it equals 2, right? And I'm going to call this M motor lift. I'm going to create another one, and I'm going to call it extend. So M motor lifts here, and then I'm going to copy this line, and I'm going to have the extend motor. Ah, crap. Extend. What goes here?
Extend.
The device ID of the extend and the brushless.
And we're not using brush because the brush will eventually lock up on us.
Correct.
I remember when we were doing those meetings.
Okay, so you'll notice here I've got some privates here that are giving me yellow squigglies and some red code down below. And the red code's because we changed the names of stuff, right? And the yellow code, the yellow squigglies are because
They're unused.
they're unused.
Same thing.
But why are they unused? Can anybody tell me that?
Because you changed the name.
Well, but
It
I'm
is
using the
correct.
name here and here, right? See how these two are lining up?
These are not used in the actual.
You're not using
like-
it in an actual function. You're declaring it in those 2 lines of code.
Okay,
You're declaring what they are.
okay.
In
Okay,
the-
so
okay,
here-
go ahead.
I just used it in a line of code and the yellow squiggly went away. So John was absolutely correct. Good job, John.
Let's see if no one
It speaks. but
different.
I
Okay.
can kind of see it took me a moment whenever you pointed out those lines, but
If you
yeah,
do
you're
M motor,
declaring it in the 2 lines, right? Yeah, the 2. I can't talk. You were going faster than I can talk. The new CanSpark lines right above the 2 lines we just added. Those are the lines that declare what it is. You can see it's declaring it's a brushless motor. That isn't technically using the item that you imported. It's declaring the item. It's adding more information to it. You never use it until you add it into a function.
Exactly. Okay, so can somebody tell me the difference between this declaration and this declaration? What are we getting? Why making this declaration and making this declaration not make this yellow squiggly?
Can you repeat that? I do not understand the full question.
Let me go ahead and answer that question with the answer, and that should explain it to you. Up here in the class declaration of timed robot, we're only declaring a name. We don't know what the flip it is. We're just saying, I want to resolve, or I want to grab the name motor lift, right? But we don't know exactly what it is.
so
When
that's
we're
just-
here in the initialization of the robot, we're still declaring motor lift, but we're giving more information. So it's like saying, hello, my name is John. But down here, I'm saying, John is a white boy who is in the 10th grade at Viola High School, right? But they're both declarations. One is just saying there is a boy named John. The second one is telling us what John actually is, right? But they're both declarations. It's just more information further down. Now, we could have made that declaration in full at the top, but then we couldn't have made it private. The reason why we make things private is so that it takes up less memory space.
Because you're only using it in that one section.
Exactly.
Having
We're
the
only
public-
using it inside robot. We don't want to use it throughout the whole entire timed robot.
Especially since, let's say you did set it public and you were thinking you accidentally set that line of code somewhere else. Well, now that other section can use it, and you might not want to be using it there. So another
Exactly.
point to make there is that it would make less for the computer to check.
Exactly. This is a global declaration. This is a local declaration. I want my name out here in the global. I want to make sure that I grab that name so I don't double use it somewhere. So I'm going to go ahead and grab the name in the global so that that name can't be used anywhere else globally. But to store and to access that memory, I only want to use it locally. That's why I'm doing that here. Y'all understand that?
Yeah.
Okay, the next set. We're restoring the factory defaults. The reason why we do that on initialization is that these SparkMax controllers are smart. They actually have ROM memory. Or not ROM memory. Volatile RAM memory. Volatile random access memory. And I said volatile, and it's wrong. It is non-volatile random access memory. In short, that's the same thing as what you and I would call an SSD. It has a very small amount of memory that can be written to and read from that will be held in storage in perpetuity. So you do not want the position of the motor to be carried over from the previous match, right? Because we're going to get it back to we're going to pull it back into the pit. We're going to hand crank crap around. We're going to tighten everything up. We're going to get it all set back to what we call the factory default, where everything's a true zero, so that when you turn on DriveStation and you get started, you want to reset the position of everything, because you don't want it to sit there and hand crank it back to tight on the lift and it still think it's at 15, right?
Right.
Okay. So we're going to set the defaults back. So here where we're enabling the soft limit direction for forward and reverse, that's pretty self-evident, is it not? We're going to turn those on. So we're going to have a soft limit for forward and a soft limit for reverse. We're setting those both to true. That's going to set the memory inside the controller to do that. And it tells us there, and it's very nice documentation. If the soft limits are disabled and then re-enabled, they will retain the last limits that they had for a particular direction. That's why we need to set these factory defaults back. Now, what our soft limits are is what we're saying is forward, the soft limit, we're setting it, so we enabled it here, which is a Boolean, true and false. Our set is an integer, or it may be a, you know what, let's check.
It's integer or double, right?
It could be an integer, it could be a double, it could be a float. So let's control space it, no suggestion.
There's code later that mentions a float. I think that's, I don't know if you can use a float for this situation or if it has to be in a different kind of sense of code. I think to use float you use the put boolean or put number below.
See if there's an F1 on this. There is not an F1 on this. So, you know what? We can test real quick. See if it's double. Double works. So it can handle a double. So you could set that with any double value that you want. Let's grab this here. That there, that there, that there, that there. Okay.
We're gonna have to tinker with that.
Okay, here we go. So now I can check that. Set the soft limit based on position. The default unit is in rotations, but will match the unit scaling by the user. Note this value is not scaled internally, so you have to pretty much play pretend with scaling. We're not going to do that. But if you look at the very top up there, it tells us that it's from the Rev library, set soft limit, we pick the direction, and it is a float. Now, a float is different than a double. Can anybody tell me the difference between a float and a double?
have never heard of a float until this session, or until I was researching earlier today. So unfortunately,
Okay, here we go. So, can somebody tell me what an integer is?
integer is just a whole number. It is a number that is or in code terms is nothing but a whole number.
Okay. What is a double?
Or okay. A double can be any kind of number that can have decimals and such. Or don't think you can have fractions in code. It can be any form of decimal. For example, as you showed earlier, 15.3 or 15 point.
Any real number.
Yeah.
You just described a float.
What?
Okay, so a float is any real number. A double, and then you haven't been told the full truth. A float is just any floating point precision, or any floating point number. Floating point means that that little decimal can go left and right, can float around. It's any real number. But with a computer only counts its precision a certain number of bits, right? So with a integers are 8 bytes. A float is 8 bytes. What does that mean? That means that you can only store 8 bytes worth of data as a number, as an integer or a float. So that means that that period, that little dot, is taking up one of your bits in your byte. Actually, it's taking up one of your bytes in your byte. So you can have a much larger integer stored numerically than you can store with a float, right?
Mm-hmm.
Because you have to store all the excess things that are to the right of the decimal. Those each take up placeholders. You have to think of it like this. It's like a box. I have a 4x4 box, and I can put so much stuff in it. Or I could put so many parts of things in it, right? So I could put 10 whole things, but I could put 5 whole things and 5 parts of things. Yeah. I can't put 10 parts of things and 5 things. I have only a certain amount of storage that I can put in there, and those take up the same amount of space as a whole, right?
99.9 is not 999.
Exactly. 99.9 is actually 4 spaces, not 3. Very good example. So, to get around that, we introduced the idea of the double. And the double means that it's double precision. You get twice the byte storage for the same value. And the CPU will take care of that for you. Now I know that's a big, long, roundabout thing to go about to say, for all intents and purposes of programming and robotics, a float is the same as a double. With one exception. We're using such a slow processor on the robot that a double takes twice as long to process as a float. Now, on a processor like what we have today, that we're hitting 4 gigahertz, which is 4 billion instructions every clock cycle. 4 billion is a big number. It's not going to matter. But when you're back over here on your RoboRio and it's running at 125 megahertz, yeah, you better believe it, you'll feel it. Especially if you start stacking doubles left and right, right? It's the same thing with like a TI calculator. The more complex you make your program in your TI-83, the slower that it's going to execute. You will feel those execution cycles based on the size of your thing. But back to this, float and double, same thing. They're both any real number. Okay?
Yep.
Alright, let's keep going. So we got our double set to 15, so we're saying that at 15 rounds we're going to stop, and then we can back it back up, back to 0. Reverse is always going to be 0 because we're always going to reverse back up to top, right? So we want, wherever that thing starts, that's where we want it to stop. To unspool, that's the one where y'all are going to have to count. Now, can anybody tell me an easy way to count the spool?
Many times it makes one full circle.
Yeah, how many times it makes one full circle. The easiest way to do that is to put you a very bright line on the end of the spool. So get you a bright piece of tape, a bright marker, Miss Cooper's chalk pencil.
I thought you meant in regard to the coding terms when it tracks. Okay, yeah, that makes sense.
And then stand out there on the end and unspool it till you hit bottom. When you hit bottom, stop it. Count those circles, that how many times it went around, and then change your code to reflect that here.
By using this, wouldn't we technically be using encoders in a way?
This is an encoder. The encoder is built into the motor on the Neo.
I would say when doing that, keep in mind whenever you reach a point in the spoil, when you're actually, like, when you reach enough spoil that the armor's still down, but if you keep spoiling any more, the armor will rise up. Mark a base 0 and a base top.
Okay, we fixed that though. It'll keep unspooling for half an hour before it wraps back around now.
You know, that's what I'm saying is that I still want to go and say, if we want to, we can have a hard or a soft limit when it goes down to unspoiling itself.
Mm-hmm.
So when you reach the bottom, we don't have to keep unraveling that spoil.
Right, right.
But that's just an unnecessary thing that we don't have to have, I guess.
Right. Oh. Okay, so we got our limits here. So what we're doing here is we're adding those to our smartboard so we can see them in real time. So that's what the put is. We're putting a boolean. We're giving it a keyword of what the forward limit is, and we're setting the forward limit. We're setting the reverse limit. We're setting this is if it's enabled here. We're getting the enabled. We're getting the actual number for the soft limit on forward and reverse on those motors. Here they are setting that motor to the joystick get Y. Which is how you're going to do it with the new joystick that you're going to be adding, which is not really a joystick but a gamepad, but we're just going to call it a joystick.
It would just be a button.
So it would be
like if you're pressing this button.
Yeah.
Yes. If not, then no.
It would be get raw button, and then I don't know. You would have to play around with it in
I think the button for the lift was 1 and 2. Yeah. I believe those are the triggers, but.
Well, no, this isn't going to be the triggers. This is going to be that SNES controller.
You're right. You're right. Okay.
So you're going to have to pull that controller out, plug it into the game station, start hammering some buttons, watch the values, and map them out. Remember, it starts on the left. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the D-pad, the hat buttons are a different set of buttons. Anyway, you're going to have to go through all those and figure all that out. The triggers are going to be, or not the triggers, but the shoulder buttons are going to be something. Map those out, figure out what's going to work the best, that's going to confuse doorknob the least. and then set her up and get her trained on that. Yeah, we established that. Miss Cooper was just saying that we needed to make sure to use the SNES controller, which is going to be the best, because lugging, as cool as it would be, is to walk over and definitively slap that down on the table, that big A fighting deck.
You can't do that. We
I
don't
mean,
have the space. It's not practical, and I'd prefer to keep half of my arm strength intact when trying to carry that piece, and with a laptop on top of that piece, trying to keep it
mhm,
from falling off.
exactly. Now we do have the new tray on the thing, but that doesn't matter. We're not taking the fight pad. We've established that. So we're going to plug in the SNES controller. We're going to program it, and that's the way we're going to go. And you know what? That controller's old enough. Y'all can, if y'all want to get out some colored markers or put some tape or make stickers or write things on it for her. I'm completely okay with that.
I'll ask her what kind of marking she'll want. Odds are she'll say she wants to put in a marker. So what I'll probably end up doing is take a piece of just a piece of paper, cut a strip, and then write down what each function is and tape it down just below it. Keep
Right.
as little of an effect on that controller as I can. Try to keep it preserved.
Eh, like I said, it's a piece of Cooper history, but it's not really worth anything. Okay, so soft limits. Y'all understand that?
Yep. If you want, I have notes that I've made from the how that I've been studying the soft limits earlier that I
Mhm.
can send.
Yeah, put it in the when we get done. Have you been putting it in your Rocketbook?
I have it digitally. I have it that I can just Control C, Control V into the coding chat.
That'll be fine. All right, so we've got no. Before I go further, does anybody have any questions about this? About the code for the soft limits?
Nope. If I do,
You can
I can
always
just
watch the video again.
yeah, exactly. That or just go check out the code, or I even have that the full section of code we went to over that you were that you didn't add. I have that in Discord in a private server that I just keep track of things in. That's
Gotcha.
where I wrote these notes in.
All right, let's go right on to the next thing then, and that is getting and setting parameters in real time. What this is this allows us from the smart dashboard to change values in real time. You can see here most of everything's the same. We've got our smart dashboard we're adding. We got our motor controller, but you'll also see that we added SparkMax low level control. Now what that does is that gives us access to the low level, the guts of the motor controller, and allows us to read more values than we would normally read. Okay? We've got our same motor. It's called M motor. It's a CAN Max. It's on a device ID of 1. It's brushless. We're
I'd like
restoring the
to
factory
mention
defaults. Do what?
I mentioned that we have that you imported or that was imported on the previous code as well.
It was, but I was making an emphasis that we're going to actually
Okay.
using a lot more of that here.
My bad.
Nope, that's fine. Let's keep going. We're restoring the defaults. That's what we want to do. If the motor is set idle, which is idlemotor.coast, then we will set the idle mode to error. We never want the motors to coast. So let's talk about coast versus braking. If a motor is set to coast, that means you run it wide open. When you let go, it keeps spinning because inertia keeps the motor rotating. If the idle mode is brake, then what happens is the motor, when you let off of it, it will throw the opposite voltage to the motor in minute bursts to stop the motor from rotating the opposite direction
Until it hits 0. Yep.
until the motor stops. So you get almost no rotation when you let off. That's why it's set. This particular code is setting an error if it's set to coast. We do not want the motors to coast ever with the Neos if they're attached to an apparatus. The only time you ever want the motor set to coast is if they're in the drivetrain. The reason why you want them to set to coast in the drivetrain is you want to be able to, it makes the inertia more predictable. Think about it. You're hauling A across the field wide open. You let off the controls. You expect that robot to keep going a little bit, right? If it broke immediately, two things would happen. One, it'd be wear and tear on the pinions because you got 120 pounds of mass that you're stopping immediately on those little tiny spur gears inside the Tough Box gearbox, right? You don't want to do that. That would be like a fat man running a sprint and then stopping and just break his legs off. We don't want to break a robot's legs
For
off.
that robot, it would cause it to topple.
Our robot, it would. You're right, John. It would be ass over tea kettle. It would just face plant. It would absolutely. Silence in the peanut gallery. Miss Cooper's like, it'll be entertaining. Doorknob. It'd be entertaining until you have to pay for it.
Suddenly, it's no longer entertaining.
Exactly. Okay, if the motor controller, so what we're doing here is it's showing us how we're going to get the values in real time and reflect them. If the open loop rate is 0, then we're going to set it as an error. Otherwise, we're going to read back the ramp rate of it. So the ramp rate is the number of loops that the motor controller output is allowed to change. So if you set it to 0, it's going to go full throttle. What does that mean? That means it will keep looping over and over and over. Have a change, 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 have a change. If you set it to like 4, it'll go, have I changed? No. Have I changed? No. Have I changed? No. Have I changed? No. And then you happen to reach over here and change it to yes, it's never going to come back around. Because it checked 4 times and you didn't make a change in those 4 times, so it's done. So with the open loop ramp rate, you want to set that to 0. Okay? So we're going to set the stick to the joystick port. Now it's showing us how you were asking about the low level stuff. We can get the voltage of the motor. We can get the temperature of the motor. We can get the output in horsepower or Newton meters on the motor.
Oh, I seen the I think the temperature thing on that. There was this one team that we played with, and they had a really weird camera on the base of theirs, but they had temperature on their dashboard.
Yeah, exactly. It's super important. That's how you get these things.
It's not always going to be temperature, though. You could use these kind of things. For example, on a side note, am I correct in saying pneumatics could do that with air pressure?
Mm-hmm. Yes, you could. So let's look at some other stuff that we can look at. motor dot get. We can get absolute encoder, alternate encoder. We can get analog. God, don't do that. We can get the applied output, which, as we found out, is the Newton strength of the motor. We can get bus voltage, which is the voltage of the telephone line. We can get the closed loop rate we've already talked about. We can get the device ID. We can get the encoder value. We can get how many times it's faulted out and failed. That may be what's wrong, Miss Cooper. We may put the bad motor back on the robot. All 3 motors were there. we may have grabbed the bad motor and hooked it up.
That would be why the lift was so slow and anyone never reset it if it was going insanely fast, right?
Yeah.
I think that could be an absolute possibility.
Swap it out to a new swap both of them out to new motors and go. Okay. Yeah, the lift has got a new motor, or the extend. Extend's got a new motor, the lift doesn't. I'm gonna make a note of that to do what, Miss Cooper? Right here, rewire Armstrong semicolon change lift motor to new motor.
So we might have figured out several problems of this call.
I know. That's why these calls are important and why I need y'all to buy in. Okay, so let's go back to get. Come on, get control space. Okay, so we get the ID, we can get faults, we can get forward limiting switch, we can get the idle mode, we can get inverted, we can invert them, we can get if it's inverted or not, we can get the last error. That will tell us when the motors are crashing, you know. We
That's
can.
something that we should look into doing, because notice how with the new motor that we were having, whenever we had that wiring problem and it would jump, would it report that error?
It would report that error. So if y'all would start taking these type of values and outputting them to the smart dashboard, you could build out and have a better way of knowing things, right?
Yeah.
Get you
I
the
can-
more you know. Okay, so that's get and set parameters. Make sure you make a note of that. Make sure you pull it down. You guys know that all this is up on Subversion. You go to Documents, and you can right click Tortoise SVN, and you can check out, hit the three dots, and the SparkMax examples are right here. You could have all this code that I'm showing you tonight is up on our Subversion. You can pull it down to your station and look at it if you haven't already done so.
There are instructions on the Discord directly if you didn't see it earlier.
Yep.
So now you have visual and physical instructions.
Alright, so that was get. Let's go ahead and minimize that. Read encoder values. Of course, once again, that is you take, it's the same thing we've been doing. We're going to get the number. We're going to put a number into the smart dashboard, and we're just getting we're calling the encoder get position. We can also get the speed of the encoder if we choose to. Really simple stuff, very straightforward, and it's well documented. It tells you exactly what these functions do. Okay, let's go and close that one. And I do believe that's, nope, there's one more, hold on. Position. Position closed loop. Now what this does is this is how you do a chain of movement based on a set of parameters. What do I mean by that? I mean we're going to have our PID tuning coefficients. So our KP is our modifier to our coefficient. That means that's how much we're going to skew it one way or another. So let's say we're expecting it to go 3 rotations per second. Changing our KP will change that 0.1 plus or minus based on what we're wanting to do. KI, that is our curve of how we want to change things, and we're doing this on an exponential level, so the curve is going to try to approach 1 but never get there. D is our value that we're going to be using. It's going to be 1, our IZ is going to be 0, Our max output is going to be 1 because 1 is as fast as we can go, and our minimum is -1 because that's as fast as we can go in reverse.
So, real quick, just to pause you, not related to code. You've gone on a couple times now, and I should have brought it up the second time. Your audio occasionally goes to muffle. Is that something related to you moving, or?
It probably is.
Okay.
It also has something to do with Choo Choo getting in my lap and trying to rub on my face.
Okay.
All right.
That would do it. I just hear the occasional muffle that lasts maybe 10 seconds.
Okay. All right. I'll try to clear that up. So back to this. You can see right here they have outlined those coefficients on the smart dashboard. Okay. They're declaring those values. They're setting everything by default to 0 until the out periodic before they start making changes. Now, they're letting the code make the motors move more efficiently based on the output range. So if P is not equal to KP, then they're going to set KP equal to P. If I is not equal to KI, they're going to set it to KI on down the road.
Now, I assume that you had to have a then function there. I did not know that you could just skip the then function. How does that work?
This is the then.
Ah, I see it now. I just missed that.
It's
My
all
bad.
one line. It's the way they formatted. I don't like it, but it is what it is.
I thought that was a. I didn't see that was a curly bracket. I thought that was another parentheses.
Nope, I'm with you. No, it's poorly done. It should have been done just like this. But they didn't do it that way. The whole reason why we put those carriage return line feeds is so that our minds can interpret it better. When it's inline like that, your mind will see those curly brackets as parentheses, no matter what. It's just the way we're wired to do. You can't even say it's color, because right here you got a parenthesis that's the same color as the curly bracket. By putting a carriage return line feed after the curly bracket, that tricks your mind into saying that's a then. Everything after this is the then. That's why we do it that way. And they go into a big write down of what's going on with their PID tuning here. And then they set the reference based on the rotations to the K position that was calculated through this if-then section up here at the top.
And if we wanted to, you could set that where you could upload that position to the smart dashboard.
Exactly. I'm going to tell y'all today that this is out of y'all's pay grade for Greene County, Greene Country. But I am showing it to you because once we get done with Greene Country and we have off season, I want y'all to start PID tuning everything and writing everything more efficiently.
Start making a code for the next robot we're going to build.
Exactly. Actually, we're going to continue to make it for this robot because remember, we're always going to have one more competition. The Ozark Mountain Brawl.
Yep, I forgot about the Ozark Mountain, or not Ozark Mountain Brawl.
Yep. Okay, that puts us at an hour and 10 minutes of hard lessons tonight. I hope that y'all got something out of this. I hope that it all makes sense to you, or at least makes a little bit of sense. Like I said, I'm going to take this tonight. I'll upload it so that y'all can access it at school if you have any questions. And if you have any questions, I will be around I will even be able to get on a call with y'all if y'all run into any problems this week. I won't be able to make it this week because even though y'all have spring break, I have work. I have done nothing but travel with you guys. So I've got to take some time and get caught up on my work.
But you'll be there Friday.
I will be there for the 4 to 10 on Friday, though. So, there's that.
Alright.
Remember that you're going to create your Green Country code and that you're going to program from that. And if you want, I'll go ahead and put this up on Subversion, or y'all can create your own. That's totally up to y'all.
It'd be nice if you put that up for now. But what I was gonna say is, what if we just Control-C, Control-V the West Coast code to the or to our Green County code, and then edit it and update it to what we need to add. Since you made a simple, since now we have a simple version of the code we need, and we can add what we need to add. Am I correct in saying that, or am I incorrect?
No, you can do it that way if you choose to.
Any word on how we should do it, Gray?
But here's the thing. Whatever y'all decide to do, John, make sure that you check in your code afterwards.
Yeah.
Don't leave it on the machine. Because every time you check it in, let me show y'all this. So every time you check in a set of code, you can actually go here and go to checkout. Let's say I want to get the AR regionals. And then I can say instead of head revision, I can say revision, and I can say show log. Well, there's only been one check-in, so there's only one version of it I can get. But if there was something with multiple versions, like let's say maybe this one, I don't know, I'm fixing to check.
West Coast has multiple.
Okay, let's try it out and see. So checkout. Let's try West Coast. So I want West Coast. Okay. And then I say show log. Yeah, okay. So let's say that the one Gray checked in on Saturday, March 4th is foobarred all to H. But the one that Chad checked in, we know that's good and solid. I can check it instead of Gray's, and I can restore back to a version prior to getting all effed up. Does that make sense? That's why Subversion is so good, is it allows us to keep a running tab of everything that was wrong. So you see here, I checked in, then John checked in from Chad's lesson 0214, and then I fixed your code for you going crooked, right? And then I checked in some more code, going back and forth and changing things. And then John checked it in. John didn't tell us what he changed. That's bad. John should be beat with a wet noodle. Followed by Gray checking in everything, the whole kitchen sink, and not telling us what he checked in. Which Gray should then be taken out back and beaten with a wet noodle. You guys, when we check in our code, let's make sure that we leave a message. Now, the reason why, well, no, I did check in code, so I ought to be beaten with a wet noodle too, because there's robot.class right there that I effed up. But I can see now where Gray, well, let me check. I don't want to put Gray on the spot, but somehow Gray checked in everything.
We use this to figure out how we end up with the Minecraft.java.
That's what I was looking for. I was wondering if this is where we got the Minecraft.java. I'm looking hard right now. Main and robot.java, but I don't see Minecraft. Okay, there's another main and robot. Okay, so this is where it happened at. I'm sure I'm just missing the Minecraft. But Gray, whatever you did on March the 4th, don't do that again. Because it looks like you checked it in like 5 times. There, he checked it in again. You got it like triple layered.
I wonder if whenever he did check in, if he changed the name of one of them to, or I'm going off of a whim here, not blaming you.
There's the third one. Remember, there were 6 of them, so there's the third one I've counted. So there's probably more up in here. And I'm guessing none of us here know what the F Gray did. I'm pretty sure. Not even Grayson knows what he did.
I wouldn't know how he ended with a Minecraft.java.
Yeah, I don't know. So let's go ahead and we're going to blame that repo. And we're going to version 11, and we're going to there. We're done with it now.
No longer exists.
We have expunged Gray's mistake from the annals of history. There we go. So that's how you fix the problem if you have the problem. But it's best if you have a problem, let me fix it. But I'm just showing y'all that we have ways. As long as you check your code in, you can't mess it up so bad that I can't fix it.
It's surely best to not have problems, but we're not there yet.
We're nowhere near there. But you guys are getting better. I'm proud of you. Thank y'all for putting the effort in tonight, because I feel like I wasn't talking to a brick wall tonight, like I have the last 2 times I've done this. So thank y'all for doing that. We've got our work cut out for us this week. You're going to make a green country code. You're more than welcome to file a new project, or you can check out the code that I have here. Either way, matter of fact, I'm going to go ahead and check this in right now. File, save all.
I have to go. My mom just called me.
Okay, man. Later.
If you have any more questions, pull up the stream.
Alright.
Yep.
Yeah.
Later. So I'm going to Tortoise SVN, and I'm going to import, not West Coast. Where are we at? Green Country. Import Tortoise SVN. Import.
I had something that I was going to say, and I instantly forgot it.
It's alright. If you think about it, you got a few more minutes while I import this.
Thinking hard right now.
Green Country. First upload of an empty template for the Green Country competition. Okay. And it's taking its good old time. Have you thought of it yet?
Nope, but my brain's been going around and thinking about the notes that I took. So earlier today, it's included in my notes, but I used the situation that we need soft limits for in our robot, and I compared it to joystick drift, which is that there's something that causes the effect to constantly go on even when not getting an input. And that's why you need a soft limit. It's to block it from ever moving without an input.
Yep, exactly.
Is there another situation, or is there another example I could put in other than joystick drift? Because it did never cross my mind any other.
Hitting the hard limits on so like picking it up, you don't want to go past the bumper. You've done that.
I also included that saying, let's see, where is it in my notes? Here it is. The situation that is leading us to learn our arm on the robot, for some reason, always goes up when not given input, very slowly, but it is still there. Setting a soft limit will allow the motor to prevent the arm from going up or down when not given input, allowing the arm to stay in place.
Exactly.
Because do you remember when we were at competition?
Or, here's another thing. Go ahead. You go ahead and finish your example.
Yep. When I was trying to pick up a cube, but the arm Like I've had the arm all the way down, but it kept going up slowly and slowly, and it just kept screwing me over. And I had to hold the button down.
Yep. Yep. So what this will allow it to do, it's not just that, John. It's the fact that it will, even if it does keep turning, it's keeping track of those turns. And when it finally does hit that soft limit, it'll stop
Yep.
in either direction. So you should be good to go there.
Yeah. These are all the notes that I took of before we went to this session, so
Mm-hmm.
that's why some of them are going to look outdated and poorly worded.
Yep.
I'm still going to upload it anyways, so.
Okay. Do you have any other questions for tonight?
For tonight, not really. It's like if I do end up having a question that we went over, I'm going to probably end up pulling up the stream as I code anyways.
Mm-hmm.
So, I should have just about all that set up, and if I found an error that's related, I don't know where something would go, then I'll probably just end up pinging you pretty soon and just asking you where it would go.
Okay. Sounds
'Cause
good,
that was
man.
the problem I had last time I was coding, was that I knew the name of something and I knew what it was replacing, but I didn't know where to put that in what general area. So I kept putting in places, for example, I tried checking out teleop periodic, auto-periodic, robot init, and none of those were right until I realized it had to be out of all of those sections and had to be directly open.
Correct. So, okay. Then you've got your marching orders, and we will catch you later. Holler at me if you need me.
Will do.
All right, man.